Hello everyone, we are Mathematical Science Diploma students from UiTM Tapa. This video is for our MAT123 assignment, which is Foundation of Geometry. The task that we have given for us is to choose two cases about applied geometry. Our first case is about fruit matrix cereal, as you can see on the screen. Cereal is a type of grass cultivated for its edible grain and serves as a major source of nutrition worldwide. Staples like rice, wheat, oats, barley, and maize are versatile crops that form the basis of many diets and traditional dishes. Known for their convenience, cereals are popular as quick breakfast options, such as oatmeal or cool cereal with milk, and are often enjoyed as simple, satisfying snacks at any time for the day. Moving on from our problem statement, a company plans to launch a new cereal brand called Fruit Matrix Cereal. The cereal pieces are creatively designed in various geometric shapes, such as cylinders, prisms, square, cube, and cones. The cereal will be packaged in a rectangular box with the following dimensions: a base of 20 cm, a height of 30 cm, and a width of 5 cm. The questions are: what is the volume of the box? What is the volume of each cereal shape, and how many pieces of each cereal shape can fit into the box?
Here is the calculation. For the volume of the box, we can use the formula base multiply with width and multiply with height. By using the calculator, the answer we will get is 3000 cm to the power of 3, and that will be the volume of the box. For the cylinder shape of the cereal, we can use the formula pi times with r squared times height. The answer we will get if the radius is 0.5 cm and the height is 0.3 cm is 0.2356 cm to the power of 3. If we use the 20% of the box volume, we can get a total of 2,456 pieces of cylinder-shaped cereal. Moving on, for the prism shape of the cereal, we can use the formula base area times height, which is 1/2 times base times height squared. The base and the height of the prism will be 1 cm, while the length is 0.3 cm. So, the total volume we will get after using the formula that I just told is 0.15 cm to the power of 3. If we use the 20% of the box volume, we can get a total of 4,000 pieces of prism-shaped cereal. Next, for the sphere shape of the cereal, we can use the formula 4/3 pi times r cubed. The answer we will get if the radius is 0.5 cm is 0.5236 cm cubed. If we use the 30% of the box volume, we can get a total of 1,718 pieces. Furthermore, for the cube shape of the cereal, we can use the formula base times width times height. The answer we will get if the base, width, and height is 1 cm is 450 cm to the power of 3. If we use the 15% of the box volume, we can get a total of 450 pieces of cube-shaped cereal. Lastly, for the cone shape of the cereal, we can use the formula 1/3 pi r squared times h, which is height. The answer we will get if the radius is 0.5 cm and the height is 1 cm is 0.2618 cm to the power of 3. If we use the 15% of the box volume, we can get a total of 1,718 pieces of cube-shaped cereal, same as the total of numbers as the cereals.
In conclusion, the cereal box with a total volume of 3,000 cubic centimeters contains 12,342 pieces in various shapes, colors, and flavors. This includes 2,456 cylindrical pieces, 6,000 smaller pieces, 1,718 of another shape, 450 uniquely designed pieces, and another 1,718 pieces. Together, they create a visually appealing and palatable mix of an enjoyable cereal experience.
Pontian, a district in Johor, Malaysia, is famous for its pineapple farms, particularly known for the sweet MD2 variety. The region's fertile soil and tropical climate make it ideal for cultivation, supplying both local and international markets. These family-run farms combine traditional methods with modern practices, attracting tourists who enjoy fresh produce and scenic views, making Pontian a unique agrotourism destination. The owner of a pineapple farm in Pontian struggles with pests affecting fruit quality and plans to use drones for pesticide application. Covering 1,000 square kilometers, the farm requires efficient coverage using either the DJI August T30 with a 5.65 km radius or the DJI August T40 with a 6.91 km radius. Each grid measures 200 meters by 250 meters. The task involves calculating the grid area, the total number of grids needed for the farm, and the estimated time each drone will take to spray one grid.
As you can see from the picture on the left, it shows a field that is split into grids, and each grid measures 200 meters to 250 meters. On the right, it shows that the estimated area of the farm is about 1,000 kilometers, and that the area of one of the grids is 50,000 meters or 50 in kilometers, which you get by multiplying the base of the grid with the height, which is 200 and 250. Also, you can get the total grid by getting the estimate area and dividing it by the area of one grid, which becomes 1000 divided by 50, and from that you get 20 total grids of the farm. Besides that, from the picture you can see a DJI Agra T30 drone that is inside a circle. The circle represents the cover range for the T30 drone to spray pesticide on the field, and the radius for said circle is 5.65 kilometers. And the way the calculations for the drone's cover range is pi times radius squared. And as I have said, the radius is 5.65 kilometers. And from that, I get 1,000 kilometers per hour. The next calculation is the total time, which means the total time for the drone to cover the whole field, which can be calculated by dividing 1,000 kilometers by the drone's cover range, which is 100 kilometers per hour. From that, I get 10 hours. So now I can estimate the time for the drone to cover one grid by dividing the total time by the total grids. Now I get the time estimated, which is half an hour for the T30 drone to cover one grid in pesticide. For the next slide, the drone used in the picture is the T40 drone, which is the upgraded version of the drone. So now I can compare between the different versions of the drone. So now we can deduce that the radius of the drone cover range is 6.91 kilometers, and the actual cover range is 150 kilometers per hour, which is better than the T30, which is 50 kilometers slower than the upgraded version. Now the total time for the drone to spray pesticide to the whole field is 6.67 hours, which is 3.33 hours faster than the last version. After that, the estimated time is 0.3 hour per grade, which is 40% faster than the T30 drone.
In conclusion, the farm consists of 20 grids, each covering an area of 50 square kilometers. The DJI T30 takes approximately 0.5 hours, which is 30 minutes to spray one grid, while the DJI T40 completes it in 0.3 hours, which is 18 minutes, making the T40 significantly faster. If time is the priority, the T40 is the better choice. However, for cost-conscious decision, the T30 is more economical, being Rm 10,000 cheaper than the T40.